Okay, this is section 2.3 in our Math Links textbook. This is on how to add, subtract, multiply, and divide rational numbers in fraction form, both positive and negative. That's the difference between grade 7 and 8 math and grade 9 math, is you have negative fractions. So the first question says calculate 9 twelfths divided by 3/8 by multiplying by the reciprocal. So for A, if I take negative 9 twelfths, and notice the negative signs in the numerator, that's where it should be, and multiply it by the reciprocal, which is a fancy word for the flip of the fraction, my answer is going to be negative 72 over 36, which is going to equal in lowest terms simply negative 2, right? Now, if we do it with B, which a lot of you probably have done in grade 8, but probably have forgotten since then, with a common denominator, what's the first multiple that 12 and 8 share? Is 24 the first one? So what we're going to do is we're going to write 24 as our common denominator. Our equivalent fractions will be negative 18 24ths and 9 24ths. Are you with me so far? We're going to divide those numerators, and we're going to divide the denominators. And notice, because we have a common denominator, what is the denominator going to be when I divide two common denominators with each other? It's always going to be 1, which means whatever that numerator is really your answer, isn't it? And what I'm going to do here is I'm just going to keep it like that, all right? And therefore, your answer will be simply negative 2, okay? Which method do you prefer, the first or the second method? It makes sense that the first method is the easiest method to get the answer. To be perfectly honest, as a grade 9 math teacher, the why it works here, the what is the intention of why does that work, why does this happen, and why do we always end up with the answer, it's a little bit more complex to explain. But multiplying by the reciprocal, when we did the modeling last year, did make sense. Question 5 says estimate, then calculate. So for our estimation in 5, we're going to take this fraction, and really what we're going to ask ourselves, is that closer to 0 or 1? 3/10. It's closer to 0. And is 1/5 closer to 0 or 1? So my estimation is pretty freaking easy. 0 plus 0. My estimation is 0. It's going to be closer to 0 than it is to a whole number. Okay? And it's going to be positive rather than negative. Once we get that, we're going to use our common denominator of 10. Make the equivalent fraction to 1/5, which is 2/10. Add the numerators. Keep the denominator. And we get 5/10 as our answer, which in lowest terms is simply a half. Question B is the sum of two mixed fractions. Now, in grade 7, when you did this, let's pretend they were positive in a grade 7 question. So in grade 7, what your teacher probably told you is you can add the whole numbers and you can add the fractional numbers and you get your answer. The problem with this is it doesn't work that way anymore. We can't do it that way because even though we think we could combine this here like this, but the problem is this quarter is also negative even though it doesn't have it. So it's technically this. But what we're going to do instead, and it's the easiest method to actually solve this, is just convert them both into improper fractions. So 2 1/3 is really 7/3. And 1 1/4, 4 times 1 is 4, plus 1 is 5. It's 1 1/4 is 5/4, but because it's negative, I'm going to put my negative symbol in my numerator. Now we have common denominator of 12, equivalent fraction of 28, equivalent fraction of negative 15. Please write this step if you haven't done so already, because when we assess it, I want to see this step. I'll highlight it again just in case you're hard of hearing or stunned. That step needs to be shown. 28 plus negative 15 is a positive 13. So your final answer is 13/12, which as a mixed fraction is 1 1/12. Question C says negative 5/12, take away 5/12. Now we have subtraction. So the nice thing about this is our common denominator is already there. Now notice how the negative sign is just with the entire fraction. So when I write this, again, I really want to keep that negative sign in my numerator, just like that. So I'm going to keep the denominator and subtract the numerators. Now, is this a positive 5 or a negative 5? It's positive. So when I rewrite that, I'm actually going to write it as a positive 5/12. Keep flip change. I get negative 10/12 which is the correct answer, or in lowest terms, negative 5/6. Sixths. It's a tough word to say. Sixths. All right. The next question says negative 2.5 take away negative 3 1/3. Convert them first to improper fractions is the easiest way to do it. Take away negative 10/3, just like that. Common denominator will be 6. First multiple they share. That's going to be negative 15/6 and negative 26. Because we're subtracting, we're going to subtract our numerators. Notice how I'm using the bracket on the negative 20 because I want to separate the subtraction sign from the negative sign. Keep your denominator. Keep flip change when you're doing subtraction. What's a negative 15 plus a positive 20? It's a positive 5. And therefore, our final answer in lowest terms is 5/6. Question E and F are our last two. Negative 5/6 plus 1/3. So I'm going to drop I'm just going to rewrite it like this. I always like to have my negative sign in my numerator. Equivalent fractions will have a 6 denominator. It's the first multiple both 6 and 3 share. So negative 5/6 plus 2/6. Add the numerators. Keep your denominator. You get negative 3/6, which in lowest terms is negative 1/2. Now notice, because it's my final answer, you can put your negative symbol just in front of the entire fraction. It's good form. Have it like that. And our last question in this number 5 is simply 3/8 take away a quarter. So 3/8 take away negative 1/4. Common denominator is 8. Equivalent fraction is negative 2/8. And once we have it written like that, we're going to keep our denominator and subtract our numerators. Now, if you're Andrew Brown, you're not going to keep flip change because you're like, I'm better than that. But if you're a normal human being, you're like, I don't like to subtract. I like to keep flip change. Not to say that Andrew Brown's not a normal human being. He's an extraordinary human being. So your answer would be 5/8. Question 7, we get into division and multiplication. It says estimate, then calculate. Now, if I'm thinking about estimation, I'm going to think about money. And I'm going to think about percentages. So 4/5 is 80. Oh, no, I'm not going to do that. Forget that. I'm going to lie to you. I'm not going to estimate division. I'm just going to calculate. So 4/5 multiplied by 6/5 is going to be 24/25 as a final answer. Don't worry about estimating that because it's way too complicated and not really that important. 24/25. So if you have 80% of a pizza, or sorry, 4/5 of a pizza divided into groups of 5/6, how many groups of 5/6 can you make from 4/5? You can almost make a group, but not quite a group. It's too complicated. It's not worth doing. The next one is multiplication of two mixed fractions. Again, just like we said before, the easiest way to tackle it is to simply change them into improper fractions. Since cross reduction is something that, generally speaking, nobody likes to do, we're going to multiply our numerators and multiply our denominators. To get 70/12ths, how many 12s in 70? I think there's 5 of them, because 5 of them is 60, with 10 12s left over, and in lowest terms, 5 5/6. Question C and D, we have multiplication again. So I'm going to rewrite this one just like this. Now, somebody said, why don't you cross-reduce, Mr. Mack? You've been preaching it all your life when you multiply two fractions together. What would negative 2/8 reduce down to? Negative 1/4. Then when you multiply your numerators, you're going to get negative 1/20. If you didn't cross-reduce, you're still going to get negative 1/20, just a longer root. 1 times negative 2 over 8 times 5 will be negative 2/40, which will still be negative 1/20 as a final answer. Question D is the division of fractions, so we're much better off to use multiplication by the reciprocal. The reciprocal of negative 4/5 is going to be negative 5/4. Cross reduction would be beautiful right here, but again, I'm not going to. When I multiply the numerators, because I kept my negative symbol in my numerators, it's really kind of nice because a negative times a negative gives me a positive 45 over a positive 40, which is 1 and 5/40ths, which in lowest terms is 1 and 1/8. 1 and 1/8. Perfectly, just like that. Any difficulties with showing your work like that? Pretty easy. What's wrong, Andrew, with that? Yeah, I know. You should, though. Question E is the multiplication of a negative fraction by a mixed fraction. Negative 3/8 multiplied by 16 thirds is what 5 and 1/3 is as an improper fraction. You know what? I can't take it because this one is such a perfect cross reduction one. What would 16 over 8 reduce down to? 2 over 1 is correct. What would negative 3 over 3 reduce down to? Negative 1 over 1. Now when you multiply your numerators, you get negative 2. When you multiply your denominators, you get 1, which would be negative 2 with cross reduction. But okay, I'm going to show you without it, just to show you that there is another part to life. Negative 3 times 16 over 8 times 3. Notice I'm using the dot for multiplication. Is negative 48 over 24, which still gives you the same answer of negative 2. In F, keep your first fraction, multiply by the reciprocal of negative 3/8, which is going to be negative 8 thirds. Multiply your numerators, you get negative 8. Multiply your denominators, you get 30. Is that lowest terms, Jack? Negative 8/30ths. What's divisible into both negative 8 and 30? 2. Give me a final answer of negative 4/15ths. Question 9 says Lori owes her mother $39. Lori paid back 1/3 of her debt, then paid back 1/4 of the remaining debt. Now watch. I'm going to show you. If I said if she paid off, so here's her debt. That's her debt. Okay? Now of this debt, she paid back a third. She paid back this much, didn't she? Here's a question for you. If she pays back a third of the debt, how much debt does she owe still? She owes 2/3 of the $39. Agreed? Okay. So I'm going to actually write that down as 2/3 of the $39 is what she still owes after she pays back a third. Does everyone agree with that? What does that look like mathematically? Actually, hold on. Let's do it simpler first. I'm going to come back. I'm going to do it the simple way first, the way that most of you probably did it. You probably said, well, what's 1/3 of $39? Or 1/3 of $39 or 39 over 1. And when you worked it out, you got 39 over 3, which is $13. Agreed? So she paid back $13, which means how much does she still owe now? The $39 take away the $13 she still paid back. She still owes $26. Agreed? So once we figured that out, then a quarter of the $26 is what she paid back next of the remaining debt, or a quarter of 26 over 1, or 26 over 4, or 13. What's half of 13? 6.5. 6.5, which means if she paid back a quarter of that $26, she paid back another $6.50. So the remaining debt, take away what she paid back, means she still owes how much money? $19.50. Now, that's the simple way. I'm going to show you the more complex way. So what I'm going to do is I'm going to shrink this down for a second. Let me just grab this all. Let me just group this together. Group it. Where's the group button? Right there. Let's just shrink that sucker down. Leave it right there. Let's ungroup that now. I probably could have done this on pause, but whatever. So there's what we did in simple way. But I'm going to go back to that rectangle that we started with and say, with the first question, if she paid this back, she still owes what fraction of the amount of money she borrowed at first? She still owes 2/3 of the $39, correct? So instead of actually calculating 1/3 and then subtracting it, we're just going to calculate 2/3 of the $39, or 2/3 times 39 over 1, or 78 over 3. And then I take my calculator. What is 78 divided by 3? Oh, that's not, what did I do there? Clear, clear, clear. Uh, 78 divided by 3 is, uh-oh, what happened there? Clear. 78 divided by 3, 26 bucks. So she still owes 26 bucks. So this amount right here, the 2/3 that she still owes is 26 bucks. She pays back a quarter of that. So she still owes 3/4 of the $26. If she paid back a quarter, she still owes 3/4 of the 26. 3 times 26 is 78. And 78 divided by 4, we already did that, didn't we? No, we didn't. 78 divided by 4. 78 divided by 4 means she still owes $19.50. So there are two ways you could have done it. Right, Grace? My way is kind of more concise. It involves no addition, just straight up genius thinking. And if you want to use that, you can. If you want to use the simpler method, this method works as well. This question will be on your test for sure, but in a different numbers and different words.